Hi everyone. We're going to go ahead and start 9.2.2 today. Hopefully you guys had a great weekend. And as always, if you have any questions about anything, continue to contact me through email or set up a meeting through Calendly. Yeah, we're just going to get right back into it today. Get right back on track here with 9.2.2. And our topic today is going to be on the Pythagorean theorem, which is one of my favorite topics, actually. Pythagoras was basically a Greek mathematician, and he created this theorem that pertains to right triangles and some special rules that apply to it. So today we're going to look at what's special about a right triangle, right? And our lesson objective for today is going to be basically you're going to identify relationships between side lengths of a right triangle as a Pythagorean theorem, and then you're going to see how we can use that theorem to apply it to solve special types of problems. Okay, so let's just jump right in here. So in 9.2.1, you saw that for three lengths to form a triangle, they must be related to each other in a special way. Today, you will investigate a special relationship between the side lengths of right triangles. This relationship will allow you to find the length of a missing side. 9-68 says, using your patterns from 9.1.1 to decide if the squares listed below will form a right triangle. So you've got three side lengths here. And you recall from the last lesson, the two shorter ones have to be long enough, basically longer than the third one, in order to create a triangle, right? Because remember, if they're not long enough, the arms won't reach, or the side lengths won't reach, and they can't connect. If you remember my example of the Tyrannosaurus Rex, it has to be long enough to reach. So in this case, 6 plus 8 is 14, and 14 is greater than 10. So they definitely will reach to create a triangle. But we want to determine if it's going to create a right triangle. And take a moment to pause here. Think about, going back to the last lesson, how do you know if I give you two side lengths? How do you know if, if I give you three side lengths, how do you know if this is going to be a right triangle or an acute triangle or an obtuse triangle? Okay, so go ahead and pause the video right here and think about that for about 15-20 seconds or longer if you need it. Okay, hopefully you paused it and you came back, and if you needed a quick refresher, maybe you looked at your notes, maybe not, but if you recall, we're going to take the lengths of the two smaller sides, we're going to square them and see how they compare to the length of the longest side, and we're going to square that. So essentially we've got 6 squared, we're going to add it to 8 squared, and we're going to see how that compares to the longest side, which is 10 squared. So 6 squared is 36, 8 squared is 64, and how does that compare to 10 squared, which is 100? Well, 36 plus 64 is 100. So if it equals 100, if you recall, that's a special rule that we learned yesterday, or the previous lesson, it's going to be a right triangle. Right? When the sum of the two smaller squares, the area of those two smaller squares will give me the same area as the largest square. Okay, so for question B, it's already doing the work for you. They've already given you the area. So you don't really need to do too much, right? Essentially, you're not going to square this because you would only square a side length, right? So they've already given you the area. So technically, 64, the side length would have been 8, right? But we don't even need to know that. That's not important right now. We just know that the area of the two smaller sides, how does it compare to the area of the largest side? And in this case, it's 144. Well, what's 64 plus 100? Let me erase this for a quick second here. 64 plus 100 is 164. And 164 is now, we know, is greater than 144. So therefore, it is not a right triangle. Okay. Bonus points if you know what type of triangle that makes. That's going to be an acute triangle. An acute triangle. Okay. All right. let me erase this real quickly here. Let's go to question C. Question C says, two squares with a side length of 5 feet and a square with an area of 50 square feet. Does that situation make a right triangle? Well, let's have a look. Side length of 5, that means the length is 5. That means I need to square that. So I'm going to have, no, let's do it over here to the side here. I'm going to change the color so we don't mix things up. I'm going to have 5 squared, that's one side length, plus the other side, because we know it's a square, all sides are the same. I'm going to add 5 squared. And how does it compare to the area? It's already given me the area of 50. So again, I'm not going to square 50. It's already given me the area of 50. So 5 squared is 25 plus another 25. Does it equal 50? Absolutely it does. 25 plus 25 equals 50. So therefore 50 equals 50, right triangle. All right. And then the question D says, explain how you know whether 3 squares will join at their corners to create a right triangle. Basically, I want you guys to pause the video right now and just put in words, into your own words. How do we know that 3 squares, when we join the corners, the vertices of each square, how do we know it's going to be a right triangle? How can you guarantee that? Okay, so go ahead and pause the video right now and answer that. Okay, so hopefully you came back, and essentially we know that this is going to be a right triangle when the area of the 2 smaller squares, so you can write the area of the 2 smaller squares equals the area of the largest square. Excuse my handwriting here. It's my stylus is not writing well on this iPad today. All right, let's move on to 9-69, and we're going to look at the Pythagorean relationship. Okay, let me erase this here. So it says, based on your work so far, if you know the area of 3 squares, you can tell if they will connect at their corners to form a right triangle. But what if you know that a triangle already has a right angle? Will the lengths of the sides be related this way? Work with your team to look more closely at side lengths at some right triangles. Okay, so it says on centimeter paper or centimeter graph paper, forming a right angle by drawing one 5 centimeter length and one 12 centimeter length shown here. So this right here, this diagram, to your right here, you're basically going to recreate that on the resource page that I've uploaded onto my haiku page for you through the link for this lesson. And if you don't have a printer, perfectly fine. It's not necessary. It just makes things a little bit easier to do. If you just watch my video, it will make sense. But let's go ahead and recreate that. Okay, so it says after you draw the 2 side lengths, they want you to connect that 3rd side right there, or excuse me, create a 3rd line to connect the 2 sides to form a triangle. Okay, so let me show you what that looks like. Let's put this over. Use my pen here, and it says we'll do one side is 5. Okay, and then the other side is 12. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 5 and 12. Make this a little bit darker. And essentially it says to connect the 2 ends to make a 3rd line so you can create a triangle. Okay, so The reason why it's pre-printed for you is because this graph paper is a centimeter grid, so it prints out in exactly 1 centimeter long squares. Okay, and because it's graph paper, we know that that's going to be a right angle. It's 90 degrees, and so it's asking us to measure that longest side. What do you guys think this longest side is going to be? Right? When we're doing this, you got to be super duper careful that you're not trying to count just visually, because very likely you will get that wrong. So right here, we're just going to measure from one end to the other. It is about right there, and as you see, that is 13. Okay. And then it says for part B, so that was part A. Part B says to measure the longest side, label it. We just did that. So we're going to move on to part C. It says visualize a square connected to each side of the rectangle. So for example, like here's one side. Pretend that this was a square that was connected to it. Okay, here's another side. Pretend that this is a square that's connected to it. Right, that's another square. It's hard to see on the video there. So, and then here's another square. Right, these are sides that belong to a square. All right, and if these were side lengths of a square, what's the area going to be? So what's the area of that square? Well, we know the side is 5. The other side must be 5. By definition of a square, all side lengths are equal. So to find the area, you do 5 times 5. That's going to be 25 centimeters squared. This one, 12 times 12, 144 centimeters squared. 13 times 13, 169 centimeters squared. Okay? And based on what we know, can we prove to someone that this is going to be a right triangle mathematically? Right? So visually, does it look like a right triangle? Yeah, sure. Looks like it. I did it on graph paper. That looks like a 90-degree angle. But how do you actually go about proving this to somebody? Well, we learned this in the last lesson. We learned it in our first problem from today. If we know the area of this small square, the area of this medium square, the area of this largest square, how do we figure that out? Go ahead and pause the video right now and try to solve that. Okay, so if you had done it correctly, you'd ask yourself the area of the small square combined with the area of the medium square. How does that compare to the area of the largest square? Well, 144 plus 25 is 169, and 169 equals 169 because they both equal each other. This is going to be a right triangle. Okay, and question D says, now they want you to try it for yourself. Okay, so again, if you have this paper, great. If you don't, no big deal. No big deal at all. It does help you if you have a ruler though. Okay, so if you just have plain paper or any graphing paper, just draw a side length that is 9 centimeters tall, because that's what problem D says, to do 1 centimeters, and then the other one is 12 centimeters. Ooh, hope I left myself enough space here. Here is 12 centimeters. Okay, there's 9, there's 12, and it's asking you to go ahead and measure, create this third side here, and just measure it. See how long it's going to be. Okay, so go ahead and pause the video, recreate this, and I want you guys to measure that. Take a guess of how long that's going to be. Okay, if you came back, you should have found that that was 15 centimeters long. And now I want you guys to do the same thing. Can you prove to someone, prove to me, your parents, your brother, your sister, that this is going to be a right triangle? Well, again, I mentioned this to you guys before. In geometry, you cannot just say, well, it looks like it's a right triangle, right? You can't just say because it looks like something that it is going to be something, right? That's not how like the courts work. If you go to jail and you have to go to trial, they can't just say, well, that guy looks guilty, so send him away. Not going to be that simple. You've got to prove it with evidence. Okay, so go ahead and prove it. Pause the video right now and do the math. Go. All right, you should have gotten 9 squared is 81, 12 squared is 144, 15 squared is 225. And if you did your math correctly, 81 plus 144 will equal 225. And therefore, this is going to be a right triangle. All right, great work, guys. Okay, now let's talk vocabulary. Let's go to part C here. It says the two shortest sides of a right triangle are called the legs. Okay, and the longest side is called the hypotenuse. Hypotenuse. Okay, so the hypotenuse is always going to be the longest side of a triangle, or excuse me, the right triangle. And it's always going to be the side that is opposite the right angle. Okay, again, always going to be the side that is opposite the right angle. And the other two ones are called legs. Doesn't matter which one you call leg A or leg B. You can switch them around. Doesn't matter. But that longest side across from the right angle is called the hypotenuse. Okay, it's very special, very important that you guys know the distinction between those side lengths. Okay, let's move on to 9-70. Oh, it says, excuse me, let's go back. It says, now use words to describe the relationship between the lengths of the legs and the length of the hypotenuse. Okay, the length of the legs and the length of the hypotenuse. How would you describe that in words? So you want to take a minute to pause, think about that, maybe jot it down, come back. We'll see what you guys get. Okay, so this is you feel free to write this down, but I feel like you would understand this. It will be obvious to you as we go along if it's not already obvious. Basically, in summary, the length of one leg squared plus the length of the other leg squared is equal to the length of the hypotenuse squared. I shouldn't say the longest leg. I'm going to say hypotenuse squared. Let's use some academic vocabulary here. Okay, hypotenuse. Okay. All right, let's move on to the last one. 9-70. Oh, not the last one, the next one, excuse me. It says the relationship that we just talked about in problem C, where we have the two legs and then the hypotenuse, where you square both legs and we set it equal to the hypotenuse squared. It's called the Pythagorean theorem. And in essence, this is it right here. So you need to write this down. Leg A squared plus leg B squared equals hypotenuse squared. Okay, go ahead and write that down right now, please. You're going to take one leg, square it. That's the other leg, square it, equals to your hypotenuse. You square it. Okay, so you might have heard of this before from other people, maybe your brother or your sister. You identify it, or they might have been used to looking at it like this. A squared plus B squared equals C squared. A is the length of leg A, B is the length of leg B, and then C is what we call the hypotenuse. Okay, so that's just another way to think about it. For right now, CPM hasn't really referenced it that way, but that's just an FYI in case you guys see it elsewhere. Okay, so problem A says to use the Pythagorean theorem to write an equation for each diagram below. So let's write the equation. Okay, problem A. Well, if I've already got centimeters squared, so if it's already squared, that tells you that that's going to be the area, right? So 9 is not the side length, 3 is the side length, because 3 times 3 gives me that 9. Right? So it's already given you the area. You don't need to square it. So we're going to ask ourselves 9 plus, because that's 3 squared is 9, right? Plus 34, what should it equal? Right? Well, that's going to equal my hypotenuse. So what's the area of my hypotenuse? Well, simple, just 9 plus 34. So 9 plus 34 is 43. Okay, and go ahead and pause the video. I want you guys to do the other two problems. Go. All right, and there are your results. Right, 8 plus 12 should equal the area of the largest square here. So 8 plus 12 is 20. That means this largest area is going to be 20. Here, it's a little bit out of order, right? So you're going to have to do a tiny bit of algebra to solve. You've got the area of the small square is 10. The area of the medium square is blank. I don't know what it is, so we'll call it x. And it must equal the area of the largest square. The area of the largest square is 25. So we have 10 plus x equals 25. And so therefore, after I solve for x, I subtract 10 on both sides. I'm going to get x equals 15. All right. Let's move on to the last problem of the day here. And it says that in 9.1.1 you found a relationship between the sides, or it's just the squares of the sides of the triangle and the type of the triangle, which is acute, obtuse, or right. You discovered that if the sum of the squares of the two shortest sides in the triangle equals the square of the length of the longest side, then it is a right triangle. Use this idea to determine whether the lengths listed below form a right triangle. So these are actually side lengths. All right, these are actually side lengths. So you're going to ask yourself, if I square each of these, meaning the small, the medium, and the large, the sum of the two smaller ones should equal the area of the larger one. Okay, so I want you guys to pause for about 30 seconds, try to do part A right now, and come right back. Okay, so part A, again, we're going to do 15 squared plus 36 squared, and we're going to ask ourselves, does it equal 39 squared? So these are big numbers right now that I don't know the answers to 36 squared off the top of my head, so I'm just going to use a calculator. Okay, so 15 squared, I know that one, that's 225. Let me just erase this to get some more space here. So 225 plus 36 squared. 36 squared is 1296. Does it equal 39 squared? 39 squared is 1521. So does 1296 plus 225 equal 1521? And you've probably done it already. It does. Therefore, this is a right triangle. Okay? Go ahead and pause this video for a couple minutes, 2 or 3 minutes, as much time as you need, and I want you guys to solve B, C, and D. Okay? Alright guys, welcome back. You should see that for problem B, 20 squared plus 21 squared is going to be 400 plus 441, and it does equal 29 squared, which is 841. So therefore, problem B is a right triangle. Problem C, if I square 8, I'm going to get 64. If I square 9, I'm going to get 81. Add those two together, I get 145. 145 does not equal, excuse me, 12 squared, which is 144. So no, it is not a right triangle. And then for problem D, 4 squared is going to be 16. 7 squared is going to be 49. If I add those two, I get 65. And 65 does not equal 8 squared, which is 64. So that is not a right triangle because they don't equal each other. Okay. that wraps it up for today. If you guys want to attempt a 9-72, I'd say go for it. It's great practice. Maybe jot down in your notes what you learned about today. It's a good opportunity to do your summary. What makes, think about this. Ask yourself, how can you identify, how can you prove that you have a right triangle, right? When given the side lengths of 3 squares. Other than that, go ahead and give it a shot on your homework, guys, which you may start tomorrow. And if you have any questions, as always, shoot me an email or sign up on my Calendly. And hope you guys have a fantastic day. I will talk to you soon. Bye.